In this video, I want to go over the quadratic formula, and more specifically, the discriminant of the quadratic formula. So I have listed here the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And what this formula does is it gives us the zeros or roots or x-intercepts, all the same thing, just different names, of our equation, of our parabola. Okay? And the discriminant is the portion here that is green in the quadratic formula. Just b squared minus 4ac. It does not include the radical. It is just the thing under the radical. And as you know, this can affect how many zeros or x-intercepts the parabola is going to have. So there's three possible scenarios listed here. I have cases that can happen with a parabola and determine how many x-intercepts there are. Okay? In case one, the parabola dips down and hits the x-axis in two different places. In case two, it only hits it exactly at one. It just barely grazes the x-axis and just hits it at one point. And case number three, the parabola doesn't hit the x-axis at all. Okay, and I want to show you what that means in terms of what your answer is going to look like in the quadratic equation. Okay, so case one is just going to be a quadratic that has two either rational or irrational solutions. Okay, so you can factor it. You might get irrational solutions. It doesn't matter. They're still real numbers, so they can be graphed on the real number line. Case two is actually the case of a perfect square trinomial. If you remember, if you factor a perfect square trinomial, you get like x minus 2 times x minus 2. You get the same answer doubled, the same zero doubled. So that means that the parabola is only going to hit once at that one particular point that is doubled. So case two is actually the case of a perfect square trinomial. And case three, the parabola does not hit the x-axis at all. And in that case, there would be only imaginary zeros, okay? So in this case, you're going to get imaginary zeros. I'll just put an I there, okay? They cannot be graphed on the real number line, so they are imaginary. So it's going to not hit the x-axis on any real number, just on an imaginary number. So it won't be shown here. Okay, with those cases, I want to let you know that you can use the discriminant to kind of determine which one of these cases it's going to be. You know, are solutions going to be imaginary? Well, it's going to be kind of obvious because you're going to have some negative under a radical and things like that. So the first scenario here is that if our discriminant, b squared minus 4ac, is greater than 0. If it's greater than 0, an example of this is, just, 36 minus 4 times 5 times 1. Okay, actually this is, I have to put a plus sign here. Or I should put a a negative 5 there to cancel that out. Okay, so this is a positive number, meaning that this plus or minus here in the quadratic formula still holds. It's just going to be negative b, in this case negative 6, plus or minus the square root of this discriminant. No problem there. We're going to get two distinct solutions out. Okay, so this is going to have two distinct, meaning different, rational or irrational solutions. All right, two distinct ones. Next scenario. If b squared minus 4ac is equivalent to 0, well, it happens to be that if you have a perfect square trinomial, this is going to happen. Okay, let's give a quick one here. So let's say we had x squared plus 6x plus 9, perfect square trinomial. So our equation would be 36, right, b squared, minus 4 times a. 4 times 1 is 1. 4 times 9 is 36. So 36 times 36 is the square root of 0. So, again, the scenario is going to be for a perfect square trinomial. What does that do? Well, we have our negative b plus or minus a 0. So negative b plus 0 and negative b minus 0 are the same thing. So this means there's just going to be one distinct solution, and they can be irrational or rational. One distinct solution. Okay. Final example. If this discriminant here is a negative number, that means there's a negative under the radical. Okay? So if there's a negative under the radical, what are you going to get? You're going to get I. So this is going to produce two imaginary solutions. Okay, two imaginary solutions. Something with I in it that can't be graphed, and your parabola is not going to hit the x-axis.